Hello and welcome back to the Higher Maths Recurrence Relation topic, and today lesson 3 we're going to look at finding a recurrence relation for a sequence. So in the previous two lessons on this topic we have been calculating U1, U2, U3, U4, U5 etc. by substituting in and evaluating. Today we are going to be given a sequence and we're going to have to find out our values of A and B. So straight into the example. A sequence is defined by un plus 1 equals a un plus b, and the first three of the three consecutive terms are u1 equals 4, u2 equals 3.6, u3 equals 2.04. Find the values of a and b. Right, I know and you guys know that u2 and u1 are linked together by the equation u2 equals a u1 plus b. So substituting in, we know u2 is equal to 3.6, we know u1 equals 4, so we're just going to substitute in, so 3.6 equals 4a plus b. We also know that u3 and u2 are linked together, u3 equals a u2 plus b, so just substituting the values for u3 and u2, so we get our second equation here. So now we need to use our simultaneous equations knowledge from National 5. We have a pair of equations in A and B. We're going to calculate the values of A and B. So 4a plus b equals 3.6. So I'm just writing it with the letters on the left hand side because you guys are used to having the simultaneous equations set up in this way. So 4a plus b is 3.6. 3.6a plus b is 2.04. So normally at National 5 we would have some scaling to do, but this is nice here because we've got plus b and plus b, so there's no need to double equation 1 or triple equation 2. So we can just do equation 1 subtract equation 2. So very important that you actually say what you're doing here. Okay, don't just write this line down without writing this part. We are trying to demonstrate to the examiner what we're doing. We're not just getting the right answer, we're making it very, very simple for him to follow our working. Okay, it's an important thing that we all need to be working towards. Okay, very, very clear working, easy to follow. So subtracting, we get 0.4a, b minus b is 0, so we've eliminated the b terms. 3.6 subtract 2.04 is 1.56. So we've got 0.4a equals 1.56, so we could have this in an uncalculator paper. So we do need to know how to solve this for a. So what I would suggest doing is multiplying both sides by 10, which would leave us with 4a equals 15.6. And then a would be 15.6 divided by 4, which is 3.9 to get that. I have halved and halved again. Half of 15.6 is 7.8, half 7.8 is 3.9. That's where that's come from. So doing it that way is a lot easier than doing 1.6 divided by 0.4, which may lead to a little bit of trouble. And then we've not calculated b yet. Substitute into equation 1, 4 multiplied by 3.9. Well, we've just divided 15.6 by 4 to get 3.9, so 4 multiplied by 3.9 is going to be 15.6, plus b equals 3.6, so that will give a b term of negative 12. Okay, so our recurrence relation, if we were asked for it, which we're not because we're only asked for the values of a and b there, our recurrence relation would be un plus 1 equals 3.9a minus 12. Okay, as always guys, let's go and try the exercise now. So exercise 15C, questions 1, 3, 4, 5, 6, 7 and 8.